That's application. So our last one, I think is kind of a cool thing. I don't think the curriculum ever mentions it, but I think it's kind of a cool thing to do. It's called style transfer. And so style transfer is basically you use convolutional networks. There's a whole paper on this that actually describes how this works. But oh, I think it's right here. So I put this in the notebook itself. But you can see that basically a way to take an image. So for example, let's take the Mona Lisa and take the another artistic photo, right? And basically transferring the style of that style image, in this case, Starry Night, into a content. And basically it says, all right, go ahead and try to basically make this picture, Mona Lisa, feel like, quote unquote, feel like Starry Night. So you can see this kind of transferring over. So let's see here. This is the original paper that shows this. So let me zoom this in a little bit. So for example, they basically took the style construct and said, okay, what do you, from the convolutional networks, what do you see in this picture within the Starry Night that actually makes it Starry Night, its style? And then you basically say, okay, here are the content specific layers, basically saying what makes this house more like a house. And so what's kind of cool is that you can basically use a pre-trained network to do this kind of stuff. And you can basically specify, well, how much do you want to transfer? So you can see this image right here was transferred into here. And you can see it's the style itself. So you can see Starry Night right here is being transferred into this image right here. Into this original image. And you can see, hopefully, is that it's not that it's changing this to Starry Night, it's trying to transfer the different style and the things that it's noticing within this picture, which actually, when you think about it, it's pretty tough to actually specify what exactly is a style. And so you can actually transfer this into these images, which is pretty cool. Art usually is really useful because art usually has a specific kind of style to it, but you could technically do it with any kind of image. They also show, for example, in this paper, how much do you actually add into the image. So you can see here basically which convolutional layer they use and how much weight they had to each convolutional layer. So you can see here, for example, they use very little weights over here. This is much more lower level features as we get to higher level features of the actual painting. I think this is the original painting right here. You see the original right here. So you can see basically the things that it noticed it the most and basically what would happen if you applied it to, excuse me, applied it to this image with a different weighting of this style to content. So it's kind of a cool thing. I think kind of a good kind of read through. You can see the mathematics and what's going on. But what's really cool is that I do actually have some example code. And this actually was inspired. This code is more or less the code that was from this Keras example, which actually has, kind of shows you, it's already pre-built. So you can basically just download this code and make it into a Pi file and just run it yourself. But I kind of like messing around with it myself. So I kind of did some extra changes and stuff like that and changed out, for example, you could specify which layers are specifically what, how much you want to adjust it by. So this is kind of a cool thing you can do. And so I actually have on Colab here, I actually have, this is actually, I had done this in PyTorch. So this is not something we learned, but it's the same concept. But basically applying the VGG19 architecture, and this is the whole model itself. So you see pretty long. They can be much longer, but you can see I have this structure here, and what you can do, I can load in these images. I can specify, okay, so here's the images. For example, I have the Mona Lisa and Starry Night right here, which is, I think it's pretty nice. So I'm going to transfer the style in here and basically say, okay, let me just play around with these weights. So for example, I actually think I've seen this yet. So I have 1.4, 1.9. These earlier features tend to transfer a lot of the early stuff that you want versus actually changing the whole image. So this is why I have a higher weight, but I kind of played around with a little bit. So I've actually seen this. So what happens is that over time, basically, I take these two images and say, okay, this is the style of this one image. This is the content of the original image. Go ahead and change this image, which is Mona Lisa, and change it so it basically has a good score. So this loss function here, you'll see it gets lower and lower. And this loss function is based on how similar is it to the style, but also still to the content. That way it doesn't change too much. So you can see here, I had it run for about 4,000 different iterations, basically pass through. And I just had it print out every 400. And you can hopefully kind of see how, I'll zoom this in on this a little bit. So you can hopefully kind of see how the image goes from this kind of image to closer and closer to more of the style of Starry Night. And sometimes if you let it go too long and have the weights too strong, it'll actually change it way too much drastically. So this, for example, shows the very end here. You can kind of see a little bit of that difference. Always got that style. I do have another example that I had from Twitter that I posted long ago. Oh, okay, we're gonna find this for media. Where am I? Oh, media. Okay, so you can see here, for example, this is something I was working on before. So this is kind of show this right here is just combining this picture right here, this style of this image to this one, and applying it over here over and over again. And so you can see here the little GIF right here of actually it changing over time and everything like that. I do have another one that I had done a while ago, which is I took these images. I don't know if you can see that as well, but those different art images, and I applied it to a picture of my dog, and just to see, you know, like how it changes. So you can see that each one has a specific style here. And then if I actually go over here, you can see this is the original image on the left, the picture on the right, and you can see probably that's similar to this Hockney image right there. And then this one's kind of interesting. This was for the pink one, and you can kind of see there's a lot of spirals, almost eye-looking stuff. And you can kind of see how that image kind of was detected. And then Starry Night, I thought was pretty cool. You can see that kind of, it has much of that swirly kind of structure that Starry Night has. So this is kind of a fun thing you can do. Again, it could be pretty artistic, but also it just allows you to see what is your network doing and kind of seeing what you can kind of apply to. So cool. And that's style transfer. You have any questions?
Nope, I think I'm good.
Okay, cool. All right, well, that pretty much ends everything I wanted to talk about for CNNs. Basically, it's some applications, different visualization of like seeing how a convolutional network works. It's kind of cool because one thing is you kind of can be a little playful, kind of be more creative with it. But it also can be really useful actually understanding this black box, like you put an input and then you get an output. Actually understanding how this black box works by trying to apply things in different ways and such. All right, well, I'll go ahead then and stop the recording.